Hello and welcome to today's class. Today we'll be looking at methods of moment for a binomial distribution. In the previous class, we were able to look at the introductory part of the method of moment, and we were able to look at the Poisson distribution. And today we are going to look at the binomial distribution. And before we continue to this lesson, please take a second to subscribe into this channel so that in case of new information, you'll be the first one to be notified. Thank you. Let us now read the question. X follows a binomial distribution with parameters n unknown and p unknown given a random variable of n, observation of x, compute the method of moment estimator for p and n when both are unknown. Now, in the previous class, we were able to look at how to work out questions related to method of moments. We said step 1, you should be able to know the probability density function of that distribution. So in our case today, we are looking at the PDF of a binomial distribution was given as n combination x. That was the probability of success, the probability of failure, where x is equals to 0, 1, 2, all the way to n. That was the PDF of a binomial distribution. And therefore, we go straight away to calculate mean. How do we find mean using this PDF? Mean, expected value of x, is always given as the summation of x, f of x, where f of x is the PDF. Therefore, let us proceed. Expected value of x is equals to the summation of I heading to 1 all the way to n. From 0, it starts from 0 all the way to n, x. Then we write n combination x, probability of success, probability of failure. Then from that step, we look at how can we write this one. The whole of this one, n combination x, can also be written as n factorial out of, this is n minus x factorial, then we have x factorial. So we replace this one with this one. Are we there? So it will be the expected value of x is equals to the summation of I heading to 0 all the way to n, x, then we replace this one, n factorial out of n minus x factorial, x factorial, probability of success, probability of failure. Now, upon reaching there, what we have to do is now we have to find how can we write x factorial, at the same time how can we write n factorial. So x factorial can also be written as x into x minus 1 factorial. Then n factorial can also be written as n into n minus 1 factorial. Are we there? So let us substitute the two. So it will be the expected value of x being equal to the summation of I heading to, now it's going to be 1 because it cannot be 0. The highest number is 1. So all the way to n, x. Then instead of writing n factorial, we replace it by n into n minus 1 factorial all over n minus x factorial. Then we write x in bracket x minus 1 factorial probability of success, probability of failure. Are we moving together? Now, this x will cancel this one, right? Yeah. Now, let us see how we can delve deeper into this. So, this n is a common factor, therefore we have to substitute it out. The expected value of x is equals to n, because this one is a common factor or a whole number, a constant, I equal to 1 all the way to n. Then we have n minus 1 factorial all over n minus x factorial, probability of success, probability of failure, x minus 1 factorial. Now, after reaching there, what we have to do is now we have to make everything to the power of 1. So what we are concentrating in is the probability of success. So it's going to be the expected value of x being equals to the summation of I being equals to 1 all the way to n, but this one is n minus 1 factorial p, then we have p minus x minus 1, then q n minus x all over n minus x factorial, x minus 1 factorial. After now reaching there, what we have to do is to take out this constant. Then the expected value of x is gonna be np, the summation of I heading to 1 all the way to n minus 1 factorial, probability of success minus 1, probability of failure minus x all over n minus x factorial, x minus 1 factorial. Now, what do we do? After reaching there, what we have to do is now we can say let m be equals to n minus 1, this one to be m, and which one? We say n, let m and y, so we say y to be this one, x minus 1. Are we there? Then if we say m minus y is equals to, so we have to subtract the 2, is n minus 1, then minus x plus 1. I think we are there. So this one and this one will cancel, so we remain with n minus x. So this one will be m minus y. Therefore, let us proceed. It will be the expected value of x being equals to np, the summation of I heading to 1 all the way to n. Then we shall have, the first one will be, because we had this one as m, this one as y, this one is m minus y, so it will be m, probability of success x minus y is y, then q, n minus 1 is m minus y all over, this is m minus y, then lastly we have y. So if you look the whole thing inside this bracket, if you look at it clearly, it comes now to the PDF of a binomial distribution. So if we have this PDF of a binomial distribution, then it means the whole of this is equals to 1. So the expected value of x is equals to np minus multiplied by 1. so meaning it is NP. Are we there? Now we will have to move further and look at the variance. Then the variance of x is always being equal to the expected value of x squared minus the expected value of x all squared. And we know this one is mean. So what we will do is, so we have to say, what is this? If we say the expected value of x squared is the same as the summation of x squared f of x. So let us find this one. Then this one is already what we have as the mean NP. So we will be having as the expected value of x squared is equals to the summation of thing to 0 all the way to n, then x squared, then it will be n factorial out of n minus x factorial, p success, q failure. Then what we'll have to do is we simplify further. What is this one? This one can be also be written as x squared can also be written as x into x minus 1 plus expected value of x. So substituting will be expected value of x squared being equals to, we take this one only, so this one is like mean, so we shall have it as the summation of I heading to 0 all the way to n. Then we have x in bracket x minus 1, so this is what we have it as x squared. Then let me move further. This one n factorial can be written as n into n minus 1 n minus 2 factorial all over, I think you are following clearly. So this one will be n minus x, right, factorial. Then this one will be x in bracket x minus 1. Then we have x minus 2 factorial. Then probability of success x minus 2. Then we shall have it as q of n minus x plus np. This one now. So this one is this one. Then what we'll have to do is this one, we'll cancel this one. Then we shall have this as constant. It's gonna be n into n minus 1 p squared, the summation of I heading to 2 all the way to n, then n minus 2 factorial x minus 2 q n minus x all over, this is n minus x factorial x minus 2 factorial, then plus np. And you know where this np came from. The x squared can be written by this one, so this is like mean, that's why we have it as that one. I think we are following clearly, so let us continue. We shall have it as this way. So if we substitute this one, the whole of this one can also be written as, if we sum like what we did in the previous mean, if we reach here, if we simplify further, it's just 1. So it's gonna be n minus 1 p squared plus np, this one now. this one, the whole of this will be 1, then we say plus 1. So if multiply, we get this one. So if we simplify further, we shall have it as x squared is equals to n squared p squared minus n p squared plus np, but variance of x is equals to n squared p squared minus np squared plus np, but minus mean squared. I think we all understood how it came about. So this one and this one cancel out. So we have it variance of x being equals to np minus np squared. So it's the same as np into 1 minus p. So variance is the same as this one, but somebody can also say variance of x is equals to npq. That person will still have the mark. Now, we are now heading towards now completing our equation and getting our final answer. But this is now how we do it. We say from the first part, from the first part, we got, say, mu prime, which is the mean, is equals to np. This means that m1 is the same as x bar. So what we do, if we say np as the mean is the same as x bar from a random variable mean. So we say if we make p the subject, p will be x bar out of n. Now let us go to part 2. Under part 2, we say the second derivative of the mean is equals to first derivative of the mean. But what we have to keep in mind is that m2 will be s squared plus x bar squared. So this one is the variance, this one is the mean squared. Whereas s is the variance, this one is the mean. So this implies that n into n minus 1 p squared plus np is equals to s squared plus x bar squared, right? So what we do is we have, but our x bar is the same as np. So let us substitute n into n minus 1 p squared plus np is equals to s squared plus n squared p squared. Let us now simplify further. N squared p squared minus np squared plus np is equals to s squared plus n squared p squared. So if we make s the subject of this equation, so it will be s squared is equals to np squared minus n squared p squared plus np squared minus np. So this one and this one will cancel out. So I'll have s squared being equals to, this one is, it is np squared minus np. So if I simplify further, this one can be np into 1 minus, this one is minus p. But p is equals to x out of n, x bar. So it is that way. So if we reach there, we have to substitute the value of p with this one. So s squared is equals to n into x bar out of n, in bracket, this one 1 minus x bar out of n. So if you simplify further of everything, and this is what we'll have, s squared is equals to x bar in bracket 1 minus x bar over n. Then, if you make n the subject, n will be equals to x bar squared all over x bar minus s squared. So n cap will be equals to x bar squared all over x bar minus s squared. Then what we have to do is now to check the value of, because we have the value of n and p, we have now just to simplify, because we had p being equals to x bar out of n, and we have the value of n, right? So we have to say but our n is equals to x bar out of x bar, this is squared minus s squared. Then what we do is now to substitute. So pick up will be x bar all over x bar squared all over x bar minus squared. So if we simplify further, pick up will be x bar minus s squared out of x bar. So this will now become our method of moment estimator for a binomial distribution. Thank you for watching this video. Please remember to like the video, share to your friends, share to your colleagues, and also remember to subscribe this channel so that in case of any information, you'll be the first one to be notified. Thank you and bye bye.